Welcome to the Next Era Energy ECSC Safety Orientation. Next Era Energy's Zero Today commitment requires building a prevention strategy that accounts for the realities of our work, including that the fact to error is normal. Our focus on prevention is unchanged, however, we understand that no one is perfect. Being human means we are prone to making mistakes. Even the most experienced team members supporting our projects and operations will make mistakes. We recognize that we will never be able to eliminate the likelihood of a workplace accident occurring. It is understood that it is not a matter of if, but when an accident occurs. Instead, we are redefining zero today to be measured by the presence of direct controls and alternate controls that provide team members supporting our projects and operations the capacity to experience accidents safely. This change aligns with our industry partners and no longer sets unrealistic expectations and pressures that all accidents can and must be prevented. Our Zero Today expectation is for team members supporting our projects and operations is to plan and execute work as if an accident will happen today. We are committed to working with industry partners to ensure that high-energy hazards associated with work tasks being performed by team members supporting our projects and operations have adequate controls. Controls that, when in place, will provide team members with the capacity to lessen the potential impacts and recover safely when an accident should occur. Thank you for your ongoing effort in support of Zero Today. In this safety orientation, we will present the following modules. Accidents happen. But why? Hazard recognition, controls, human performance principles, human performance tools, reporting, final takeaways.
Module 1. Accidents happen, but why?
We want to spend a few minutes to go over why accidents happen. We understand that accidents will likely occur in the course of work being performed in support of our projects and operations. In fact, it is not a matter of if, but instead of when will an accident occur. Our focus is on reducing the frequency and severity of the events. We need your help to do so. We want to spend a few minutes going over the most common factors that contribute to almost every workplace accident, including the following: high-energy hazards, human factor errors, and stressor states. The good news is that most accidents are not primarily caused by a lack of knowledge about the hazards involved or the procedures for dealing with them. Most team members supporting our projects and operations have a general understanding of the common hazards in the workplace and potential effects or outcomes if they are exposed to them. For example, most team members know that a fall from a significant height could be fatal or will likely mean a trip to the ER. Most workplace accidents involve familiar hazards and follow these two general rules. They usually follow a simple, regular, and consistent pattern of unintentional human factor errors, like getting caught in the line of fire. They almost always occur when a stressor state like frustration or fatigue is negatively affecting the team members involved. Accidents resulting in a significant injury or fatality, SIF, follow the same general rules. However, the team members involved are exposed to a high-energy hazard source. We will talk more about high-energy sources later in the presentation. In this slide, we will talk about human error factors that may contribute to workplace accidents. Unintentional human error is almost always in the mix somewhere when an accident occurs. When team members take their eyes off the known hazard and lose the reflexive ability to avoid interacting with it, Stop thinking about the hazard and do not process the possible sequence of events that could lead to contributing to an incident. Put themselves or their coworkers in the path of the hazard. It's not just safety mistakes that have undesired outcomes. Almost every unintentional error we make has some negative consequences. At this point, it's worth asking what causes team members to make unintentional errors. After all, no one wants or likes to get hurt or wants to deal with the immediate consequence of pain and suffering. In this slide, we will talk about stressor states and how they may contribute to a workplace accident. If we take an approach to determine a few causes of the majority of errors, then we may be able to uncover some common causes of workplace accidents. Stressor states are built into our daily existence and reliably lead to unintentional errors that waste time and money, damage relationships, and result in accidents that could get team members or their coworkers hurt or killed. Common stressor states include feeling rushed, being frustrated, and being tired. If you feel rushed, don't give in to self or pre-imposed schedule or production pressure. The correct way is the safe way. Avoid taking shortcuts. If you feel frustrated, step away from the task and ask for help. Don't allow your frustrations to cloud your judgment. If you are tired, it's important that you get your rest and maintain a healthy lifestyle. Be cognizant of your schedule and physical or mental state and ask for breaks if you feel you need them. Let's take a few minutes to discuss the factors that influence team member safety at work. There are 3 common factors that shape individual team member behavior: a crew safety climate and the overall site's safety culture. They include the physical environment and the implementation of safe work controls, team members' personal safety commitment, hazard awareness, and work skill, positive motivation and mentorship to perform work safely from coworkers, supervisors, and managers. When evaluating the physical environment and safety controls, team members should ask themselves the following questions before performing an assigned work-related task. What am I being asked to do? What am I being exposed to? How can it hurt me? How can I protect myself from it? Are the safety controls in place? Do I have what I need to work safely? Team members' personal safety commitment, awareness, and skills. Have I been trained to do it? Do I understand what I'm being asked to do? The last factor influencing team member work behavior is the motivation and mentorship of coworkers, supervisors, and managers. Team members should ask themselves the following questions to ensure that their safety is the priority. What is the objective? What is being measured and weighed? What am I being told to do? What am I being told to prioritize? What is getting recognized and rewarded? What is being allowed or tolerated? Safe work behavior is heavily influenced by all 3 factors. An individual team member's response to the questions is not only impactful to their behavior, it's also impactful to their coworkers. Unsafe acts, behaviors, and conditions are common contributors to accidents and injuries. Let's get deep and talk about neuroscience and how it influences team members' behaviors. Human brains are designed to automatically learn to recognize and fear hazards and environments that hurt them in the past. One of the built-in teaching mechanisms used to create this subconscious avoidance response is pain. Pain is hardwired into each of us so that we can learn from our repeated injury events and build a subconscious library of what caused it. Eventually, these experiences cause us to begin responding automatically at the subconscious level to the environment or hazards associated with the painful event. This eventually causes an in-the-moment response subconsciously that helps us avoid interacting with the same hazards or environments when we encounter them again in the future. The problem with using pain as the primary teaching tool is obvious. We had to suffer the pain in order to build the library. Unfortunately, we don't get to choose the level of pain or frequency of occurrence that is needed to cause the subconscious avoidance. In some circumstances, we may not survive the first exposure to learn from it and trigger a future response. The good news is that the subconscious part of our brain that builds our individual pattern library can't distinguish between real and virtual exposures. Our brains can be rewired or manipulated to create the same subconscious response by reframing past experiences, to consider additional lessons that can be learned from past experiences. Listen to others' experiences to learn vicariously through them. Imagining experiences and picturing the possible severe negative outcomes that could occur after a near miss or minor injury. Module 2. Hazard Recognition. What's out there and how can it hurt me? Hazard recognition is the first step in, and the key to staying safe. We have to be able to recognize potential hazards in order to protect ourselves from them. Let's walk through a quick exercise on hazard avoidance. Step 1. Hazard recognition. Team members need to review the work environment and steps associated with performing their assigned task to identify potential hazards that they may be exposed to while performing the task. This is a key step in work planning discussions. Step 2. Risk perception. Team members need to determine the likelihood of being exposed to and impacted by the potential hazard while performing the assigned task. Step 3. Risk tolerance. Team members determine the severity of the potential hazard and the risk tolerance for it. Step 4. Behavior. Team members choose how to behave regarding the hazard while performing the assigned task and what controls to put in place to protect themselves from it. The problem is that team members sometimes have a difficult time recognizing hazards. Team members can't respond to a hazard that they don't notice. If they can't identify the hazard, they won't be able to progress through the remainder of the steps to protect themselves from the hazard. We have to do a better job in identifying hazards during pre-task planning discussions. In the following couple of slides, we'll go over a couple of tools that, when used correctly, can help team members with hazard recognition. Accidents and injuries arise from the release of energy from hazards. If team members don't notice potential hazards, then they certainly can't do anything to control them. The hazard recognition problem isn't their fault. Cognitive biases in humans make some hazards easy to notice, but demand heavy attention and consideration for others. Some hazards are just easier to spot than others. Team members typically identify about 67% of hazards that involved gravity, but only 40% of electrical hazards, and only 19% of chemical hazards. When used correctly, the energy wheel shown to the right of the slide helps team members recognize greater than 30% more hazards. Team members should use the energy wheel during the initial development and revision of Standard Operating Procedures (SOPs) and Standard Work Instructions (SWIs), during pre-task planning discussions, when utilizing the 2-minute rule, and other times as needed to help identify hazards. The energy wheel is simple to use. Team members should rotate around the icons contained in the energy wheel to help evaluate the work environment to determine if an associated hazard is present. Evaluate the work task to determine if an associated hazard will be created by performing the assigned task. The energy wheel is only one part of a safety program grounded in energy-based hazard recognition. Along with understanding sources of energy, Team members can improve their safety outcomes by looking out for the specific task-based hazards that place them at a risk of a significant injury or fatality. Once potential hazards are identified, team members can work with their supervisors and managers to ensure that appropriate controls are put in place to protect them from the hazard while performing their assigned task.
Injuries and significant non-injury events can result from the release of energy from hazards in the workplace. Not all hazards are the same. Hazard recognition is only the first step in staying safe. All hazards are a potential energy source for a workplace accident or incident. The energy source potential for the hazard can be quantified. If team members encounter a hazard having less than 350 foot-pounds, may result in a first aid. Between 350 to 500 foot-pounds, may result in an injury requiring off-site medical care. Greater than 500 foot-pounds, may result in a serious injury or fatality. The 13 high-energy hazards identified in the graphic to the right have been identified to have high-energy impact potential if team members come in contact with them. Together, these hazards present the greatest risk to significant injury or fatalities to team members. Let's take a few minutes to go through each one. Number 1. Suspended loads. A suspended load is anything lifted above the ground or lowered to the ground. The greater the mass of the load and its height above the ground, the greater the potential energy, and greater the hazard. Tools, material, equipment, and components are commonly lifted and lowered during a construction project. In some cases, team members themselves could be considered suspended loads when they are lifted or lowered in baskets or work platforms to perform work-related tasks. Any suspended load has the potential to be dropped if something goes wrong. Even when an equipment operator is not moving a suspended load, no one is to be directly under the suspended load. Work is to be planned and sequenced to avoid team member exposure. Barricades are to be set up to prevent team members from entering fall or drop zones under suspended loads. Number 2. Heavy rotating equipment. Chainsaws, trenchers, augers, pulleys, gears, drive shafts, cable reels, conveyor belts, pumps, drills, and grinders are few examples of essential tools used on construction projects. The rotating motion of these tools and pieces of equipment can be dangerous to team members. Rotating equipment can grab hold of hair or loose clothing and pull team member into the tool or equipment, leading to significant injuries. Guards and/or shields should be installed to protect team members from rotating parts on equipment. Body parts, hair, and loose clothing should be kept away from rotating tools and equipment. Tight-fitting PPE should be used by team members operating or working near rotating tools or equipment. Tools and equipment should be equipped with auto-sensing devices that shut off when an obstruction in the rotating mechanism is detected. Number 3. Steam. People encounter steam every day, but rarely in strong enough concentrations to cause a significant injury or fatality, SIF. On some construction projects, steam presents a real danger to team members who encounter it. Steam produces large amounts of energy under pressure that can transfer to team members, causing severe burns. Steam under pressure can also pose a risk of explosion. Team members working in environments with pressured steam must be trained. Valves should be operated remotely where possible. Number 4. Arc flash. Arc flashes occur when a flashover of electric current diverts from its intended path and moves through the air from one conductor to another or to the ground. They can arise from several sources, including dust, falling tools, accidental touching, condensation, material failure, corrosion, and faulty installation. An uncontrolled release of industrial electricity can contain enough energy to electrocute a team member. The severity of an arc flash injury varies based on the proximity of the team member to the electricity, the current involved, and the duration of contact. Circuits are to be de-energized prior to commencing work whenever possible. National Fire Protection Association (NFPA) approach boundaries are to be adhered to when working near energized equipment. Equipment is to be tested to determine its safe state before performing work task. Insulated tools and personal protected equipment is to be used by qualified and authorized team members. Number 5. Fire with sustained fuel source. Construction project tasks like welding, grinding, burning, and operating equipment introduce potential ignition sources can lead to a fire if there is a fuel source in the vicinity. Any uncontrolled fire is concerning for team members, but fires with a sustained fuel source are especially serious. While team members can typically stop small, isolated fires, fires with a sustained fuel source, say dry vegetation, aren't so easily contained. Large volumes of fuel increase the potential energy of a situation and turn minor fires into long-lasting, fast-spreading intense blazes with real risk to team members, material, equipment, and neighboring properties. Be aware of the site emergency response plan and associated responsibilities. Perform hot work task under the requirements outlined in a hot work permit program. Keep ignition points away from sustained fuel sources. Have adequate fire control measures immediately available. Number 6. Excavation or trench. Construction activities commonly involve digging and trenching, which pose a unique set of hazards to team members. Team members may need to create and enter excavations or trenches to perform work-related tasks. A small amount of dirt may not seem dangerous, but 1 square yard can weigh more than 3,000 pounds, the weight of a compact car. This small amount of dirt is enough to fatally crush and suffocate team members. Team members rarely survive trench or excavation collapses, which is why OSHA considers the work among the most dangerous construction activities. Soils are to be classified by a competent person to determine type and cohesiveness. Trenches or excavations are to be sloped, benched, shored, or protected with shielding systems prior to entry by a team member. Trenches or excavations are to be inspected prior to each shift to determine if they are safe to enter prior to each shift and after any disturbance. Safe access in and out of the trench or excavation is to be provided to team members. Trenches or excavations are to be closed as quickly as possible after opening them. Protective barriers are to be installed around trenches and excavations to keep unauthorized team members from approaching and entering them. Number 7. Fall from elevation. Slips, trips, and falls are the leading cause of workplace injuries. Any fall can cause injury, but falls from elevation are particularly hazardous. By falling from a height of 4 feet or more, team members can generate enough acceleration, increasing the overall energy in the incident that may turn a simple stumble into a more significant energy. Actions should be taken to substitute drones or other technologies where applicable to keep team members from needing to work at height. Fall arrest systems should be utilized to protect team members from falls at or in excess of 6 feet. Portable ladders are to be secured in place while in use. 3 points of contact are to be maintained while ascending or descending. Number 8. Electrical contact with source. The risk of electrical contact with sources is similar to an arc flash, but even more severe. In this case, team members may sustain injuries when they become part of the electrical circuit. Similar to an arc flash injury, the risk of significant injury or fatality, SIF, event is high and its severity varies based on the electrical current and the duration of contact involved. Electrical sources can convey even larger amounts of energy than arc flashes because team members may remain exposed to the source continuously rather than a brief flashover. Electricity can cause team members' muscles to contract, preventing them from pulling away from the source and, in turn, increasing the duration of exposure. Depending on the voltage, current, and duration of contact, fatal electrocution is possible. Event and non-fatal incidents, though, the injuries from electric shock and burns can be severe. Circuits are to be de-energized prior to commencing work whenever possible. National Fire Protection Association, NFPA, approach boundaries are to be adhered when working near energized equipment. Equipment is to be tested to determine its safe state before performing work task. Insulated tools and personal protected equipment is to be used by qualified and authorized team members. Barriers are to be installed between team members and energized electrical equipment to prevent exposure to unqualified team members. Number 9. High dose of toxic chemicals or radiation. While not likely during construction, team members may be exposed to harmful substances and noxious fumes while performing work-related tasks. High doses of these chemicals and compounds can cause acute health issues for team members. Unlike swinging cranes or unsecured platforms, chemicals are less obvious hazards, which makes them easy for team members to miss. Still, they contain vast potential energy that can disrupt human health as readily as any heavy equipment. Because chemicals and compounds are so dangerous and easily overlooked, extra care must be exercised to call attention to them at project sites. Exposure should be limited to them as much as possible, including team member rotation to reduce frequency of exposure. Team members should be trained on potential exposure sources, associated risk, symptoms of exposure and controls to follow to limit exposure. Chemicals and compounds are to be stored, handled and disposed of in accordance with OSHA guidelines. Number 10. Explosion. Risk from explosions come from a range of sources such as striking a gas line, improper labeling of reactive substances, damage to equipment and/or their fuel sources, flammable atmospheres, etc. Explosions by definition are a vigorous release of energy. If uncontrolled, they present a significant risk of causing a significant injury or fatality to any team member within the blast radius. Since explosions occur suddenly and without warning, extra diligence to identify any risk of explosions during the pre-task planning discussions. 811 is to be called to locate utilities before excavating and/or trenching. Hazardous material training is to be performed with team members who are exposed and/or working with reactive substances. Hot work should be performed under a hot work permit. Hot work should be performed away from sustained fuel sources. Non-inductive tools or equipment tools should be used in potentially explosive atmospheres. Number 11. Mobile equipment and workers on foot. Mobile equipment such as backhoes, drills, drivers, loaders, rollers, and light vehicles are foundational to construction projects, but they're also high-energy hazards, especially when operated around team members on foot. Any moving equipment generates lots of energy. It is often easy to identify, but it can move quickly and be difficult to get away from. Where possible, actions are to be taken to keep team members out of designated paths of travel for mobile equipment. Flaggers and spotters are to be used to escort mobile equipment in heavily congested areas. Team members working on the ground are to wear high-visibility clothing and safety-toed boots. Mobile equipment is to be equipped with functional bidirectional alarms. Mobile equipment is to be equipped with mirrors and/or camera systems to limit blind spots or issue proximity warnings to operators. Number 12. Motor vehicle incident as occupant. Operating or being in a motor vehicle or mobile equipment is a necessary part of work, and collisions that injure occupants may be an unfortunate occurrence. Vehicles and mobile equipment builds up a lot of energy as it moves, which raises the likelihood of an incident being severe. Team members are to be deemed qualified, fit, and authorized to operate vehicles and/or mobile equipment. Rules of the road and project site are to be adhered to. Seat belts are to be worn by the operator and all occupants while the vehicle and/or mobile equipment is in motion. Operator distractions such as mobile device use is strictly prohibited. Number 13. High temperature. Many tasks on construction projects may put team members at risk for contact with high temperatures like welding, cutting, soldering, grinding, and burning. Any hot work contains significant energy that can transfer to team members, causing serious injury unless they take proper precautions. Team members are to be deemed qualified, fit, and authorized to perform activities that produce high temperatures. Team members working in the areas of high temperatures are to be trained on safety controls. Team members performing or exposed to high-temper actives are to be provided and make use of high-temperature PPE. Cover-ups or protective boundary barriers are to be used to prevent contact with high surface temperatures. To put it simply, the 13 high-energy hazards is the stuff that kills you, also called sticky. These hazards present the greatest risk of significant injury or fatalities to team members. Awareness of these hazards, along with application of the energy wheel, can help team members identify and implement controls to protect themselves and their coworkers. Identifying and prioritizing the energy is an important first step. The next step is to ensure adequate controls against hazards, especially high-energy hazards.